So, greetings, students. So, we have been dealing with your fourth unit. Okay. So, we have been dealing with your fourth unit. So, again, I will be giving an overview of the subject. That is, in the first unit, we have seen about your over voltages. Okay, what are the different type of over voltages? How it is caused due to the external factors. Then how it is caused due to the switching service we have seen. So in the second unit, we have seen about your dielectric breakdowns. That is how in an insulator medium, how the breakdown occurs. Then third unit dealt with your generation of your high voltage. Okay, how your high voltage is generated, we have seen. So in the fourth unit, we have been dealing with your voltage measurements. Okay, voltage measurements technique. So in this, we have seen about how to measure your high voltage for your DC. Okay, how to measure your DC high voltage we have seen. After that, we have seen about your AC. So in that AC, we have mainly seen about your Tesla coil, one of the very important phenomena and what you can say. It's a very reliable measurement technique. Okay, so those Tesla coils are the one which are being used for the wireless transmission. The wireless transmission also, they are making use of such kind of uh, Tesla coils. Okay, so in today's lecture, we will be dealing with your high impulse voltage measurement. So this is the thing we will be seeing in today's lecture. Okay, we are going to see about this. So in this, how you are going to measure your impulse voltage will be seen. Okay, so these are the four methods for measuring your impulse voltage. Okay, so first one is your peak voltmeter with capacitor potential divider. Okay, this is more or less similar to that of the capacitor measurement for your DC voltage. What we have used in the DC voltage, the same thing will be repeating over here. The second also, series capacitor voltmeter we have already seen for the measurement of a DC. The same thing will be repeated over here, but here for your peak. For the peak value will be taking Y means we are dealing with the measuring of your impulse voltage. So we will be taking into the account of your peak voltage only. Okay. So the third thing is digital peak reading meter. Okay. This is another one technique. And the fourth one is based upon your CRO. CRO based measurement techniques. Okay. So this is your fourth one. So moving on. Starting with your peak voltmeter with a capacitor potential divider. So before getting into this, you have to know about your impulse voltage. So you know about the impulse voltage, right? So what is mean by impulse voltage and what are its characteristics? How its characteristics are defined? Okay, mainly its characteristics are defined by your its wave time, that is tail time and your front time. Okay, wave tail time and wave front time. Based upon these two parameters, your impulse voltage will be uh, defined. They are the two main characteristics of the impulse voltage. So in general, your impulse voltage is nothing but your a very short time period, your voltage will be reaching a very high peak value. Okay, the magnitude of the voltage will be very high within a very short time period. So that corresponds to your impulse voltage. The short time period will be in the order of your microseconds. Okay. So now how we can measure such kind of very high impulse voltage will be seen. So the first thing is based upon the peak voltmeter with the capacitor potential divider. So here what they'll be doing is it is more or less same as that of your voltage divider technique. So in the voltage divider technique, what you'll be using is that you'll be making use of resistors. Okay, resistors to be connected in terms of the parallel concept. But over here, what we will be using is instead of a resistor, we will be replacing it with the capacitor. Okay, so that's the main difference. So here you can see two capacitors are connected in parallel. Okay, and there's also a resistor. This resistor will be mainly used for the protection purpose. Okay, so what they're saying is that the voltage across C2, okay, C2 voltage is made use of in charging the storage capacitor CS. So in general, what they'll be doing making is that they'll be applying your impulse voltage at this point. Okay, and the measurement will be done at this point. That is this VM. This VM over here we'll be making the measurement. So in general, the voltage across your CS is what will be the voltage you have to measure. Okay. So next RD is the discharge resistor. Okay. So this is RD. As you know, this is the discharging area. So this is a discharge resistor which is employed to permit variation of VM. Okay. In case of variation in VM, so this is what RD is what permits it. Okay. CS is charged. CS is nothing but this is the thing. So which you are going to measure. Okay, is charged to a voltage which is proportional to the peak value to be measured. So this third point is very very important. Based upon your uh, charging capacitor CS voltage, it will be directly proportional to the voltage which you will be applying. Okay. So the indicating meter is either an electrostatic meter. So the meter what you can use may be an electrostatic meter. Okay. The discharge time constant. Here they are giving the time constant. So here there's an RC circuit. Okay, it is an RC circuit in the discharge part. So you'll be taking discharge time constant tau equal to RC, and this tau value will be from 1 to 10 seconds. So based upon this tau value only, your capacitor and your resistor will be chosen. Okay. So the limitation is that here sometimes the discharge error occurs if the capacitor and the resistor are not properly chosen. Okay. So next is the series capacitor voltmeter. Okay. So you have already studied about series capacitor voltmeter, but this is a series capacitor peak voltmeter. So based upon the measuring of your peak voltage here we can see. Okay. So this method, another name is Chap-Protsky method. So this is mainly used for measuring your peak voltage. So here, when a capacitor is connected to a sinusoidal voltage source, okay, here you can see it. So the voltage source here they have taken as current, okay. So a capacitor is connected to this, okay. So this charging current is given as IC equal to j omega CV, okay. So this is what your IC for the instance of t, okay. And from this, the measuring voltage Vm will be 1 I by 2 pi Fc. It is I by omega c. Okay. So here is your Vm. Okay. From this Vm, you can keep it this side, and other things you can bring it down to the downward, and you can take the modulus value. Okay. So here, if a half-wave rectifier is used, in case of half-wave rectifier, the arithmetic mean, okay, aim of the rectifier is proportional to the peak value. Okay. So the previous case, what you can see is that the discharging voltage will be directly proportional to that of the applied peak voltage. But over here, this if you in case of a half wave rectifier, you have to take the that average value output value of your rectifier. This average output value of the rectifier will be proportional to that of the peak value of VA. Okay, so this is the concept over here. So the drawback is that it is valid only when both half cycles are symmetrical. So this method might be a failure in case of your asymmetrical waveforms. Okay. So also this method is not suitable when the voltage waveform is not sinusoidal. Okay. So which indirectly corresponds to the asymmetrical waveform. Okay. So coming to the next method is a very interesting method, digital peak reading meter. Okay, so this is one important question. This one and CRO based measurement are important questions. So you can expect for your university, even university exam, you can expect these two. So here, what they are saying is that they'll be making with some blocks. Okay, so the first block corresponds to a voltage to frequency converter. Okay, second block is your gate circuit. So gate circuit means it is the circuit which is responsible for in power electronics you might have studied. It is responsible for the firing pulses, like that of gate circuit. So that is a gate circuit is a thing which gives the control pulses. You can have like that. Okay. Third one is a readout counter. Okay. So it is a counter circuit. In your digital logic circuit center, you might have studied synchronous counter, asynchronous counter. So like that, it's a counter circuit. So what they are saying is that instead of directly measuring the rectified charging current, okay, so in the previous cases and all, what we'll be doing is that we'll be measuring out the rectified charging current. Okay. So here what they're saying is that proportional analog voltage signal is derived. Okay. So here you will be giving a high voltage. Okay. And over to here, that is here you'll be giving a high voltage. And this high voltage will be able to generate a analog signal, okay, which is proportional to that of the frequency at which the high voltage is. And this will be directly proportional to each other. Okay, that is based upon the high voltage, an analog signal will be generated using this circuit, and this analog signal is what will be given to these blocks. Okay. So here your measuring will be based upon your frequency measurements. Okay, so the voltage what you will be applying will be directly converted to a frequency converter. Okay, you can make use of some kind of cycloconverters which we have studied in your power electronics, and using that kind of converters, the voltage value will be directly converted into a frequency value. Okay, so here they will be saying the frequency ratio Fm by F is measured with the gate circuit controlled by a AC power frequency F, okay, and a counter that opens for an adjustable number of periods. Okay, so during this interval, the number of impulses be counted, that is n. So this n value will be equal to the Fm into the change in time period. Okay, that is the adjustable number of periods. Okay, this will be equal to P into Fm by Ef, okay, which is equal to here 2 PCVM into AR. So this is got from your circuit. Okay. So here A represents the conversion factor which converts your AC to a DC converter. Okay. So this is what the basics of your digital peak voltmeter. So you just write draw the diagram. They explain like a story. Okay. So this is one thing. So next one is your CRO based measurement for impulse voltage. Okay, this is very important. Okay, from this one slide itself, you can easily write up to a 13 mark, but it is a very important and repeatedly asking this question. Okay, so you already know the basic concept of CRO. So in the CRO, it's nothing but will be having an electron tube wherein it will be having two electrode plates, X plate and your Y plate. Okay, and you will be passing a very high electron beam. Okay, so this CRO tubes or CRT they will be seeing will be we have been used in your very old television boxes. Okay, In a very old television box, you can see such kind of CRO, CRT tubes. Okay. So what they'll be doing is that this first one is your amplifier, plug-in amplifier. Second one is your Y amplifier. So I have said right, it will be consisting of two sets of electrodes. So one is your Y amplifier, and the sixth one corresponds to your X amplifier. So one will be of a vertical plate, and another one will be of a horizontal plate. Okay. So the three will be a inter-relay line. So this inter-relay line is the thing which matches both your the signal from your Y amplifier and your X amplifier. Okay. So fourth one is your trigger amplifier. Okay. So that is after the passing through the Y amplifier, the signal sometimes may be getting weaker. So again, it will be triggered to this fourth circuit. And after this, it will be passed to a sweep generator. Okay. So sweep generator is the thing through which, based upon the what you can say, the frequency, it will be passed to your X amplifier. Okay. So your X amplifier will be having your horizontal plate, and Y will be having your vertical plate. Based upon this only, your old this concept only, your old television systems have been working. So the very high electron beam will be passed through this circuit. Okay. So okay. So what I'm saying is that modern oscilloscopes are steel tube hot cathode oscilloscopes with photographic arrangement for recording waveform. Oscilloscopes are fitted with good camera for recording. So based on here, generally applying a voltage. So it will be passed through this. Okay. The message signal is transmitted to the CRO. Yeah. Normal coaxial cable. Okay. So you see our coaxial cable in the TNT subject. Okay. So using a normal coaxial cable, a very high voltage will be passed through the CRO tube. So the delay is obtained by external connector partial long cable to give the necessary delay. Also, the delay can be generated through this third box also. The triggering is used to initiate or start the oscilloscope time gauge. So this is what is used in your CRO, which we are using for the measurement. Okay, the same thing only here also done. Instead of in the laboratory, we'll be making use of the voltage measurement, right? The same CRO will be this. It corresponds also. Okay, so that CRO and this are both the same. So this is an important question. Okay, they have been repeatedly asking this question. You can expect this question for your university also. Apart from this, the other possible questions are these are the four things. This is with respect to your impulse voltage measurement. Okay, so in this another important question is digital peak reading meter. Okay, digital peak reading meter is also an important question. So with this lecture 4 is getting completed.